Hello, 8th grade science students. I'm going to briefly give you an overview of how to complete slide 14. So yesterday, we started to learn how individual lonely electrons in a Lewis dot diagram of an element that has at least 4 electrons, so one on each side of the Lewis dot diagram, can share those electrons with other atoms in order to make covalent molecules. So this means that covalent molecules, you can make long chains of carbons or nitrogens or other things. You can make very complicated molecules, things like proteins and DNA. We're just going to do a very simple one on this page. So carbon has 4 unpaired electrons. We can pair up 1 hydrogen with that. And now this hydrogen is stable because hydrogen only needs 2, unlike most others that need 8. But the carbon still only has 5. So to deal with this, we need to keep pairing up electrons. So I'm going to drag this hydrogen over here, turn it around. We'll pair this one up as well. We can turn around our little bubble here. There we go. So now there's 2 hydrogens bonded to the carbon, but the carbon's still not stable because there's 2 unpaired electrons. So let's go and grab a 3rd hydrogen. We'll go and bond that at the top. Place that right there. So now we have CH3, but there's still 1 unpaired electron. So let's add 1 more hydrogen. Pair it up there as well. So this is 4 single bonds, and the molecule is CH4 or methane. That wouldn't necessarily be the standard name for a covalent molecule, but it's standard within organic chemistry. We're going to learn how to name them here in a second as well. So one thing you're going to notice is that naming these is a little bit trickier than ionic compounds because you can put different numbers of them together. So I could put extra carbons in a row. I could put extra nitrogens in a row. With ionic compounds, the charges would match up and you'd only get certain combinations. You can't add more or less. They have to be in the same ratio to make the charges cancel out. But in this one, you might be able to arrange the same 2 elements in different ways. So for example, if I put a carbon right here next to the first carbon, I could make a longer chain. Same elements, but different amounts. So because of that, we have to use prefixes in the name to tell someone how many of each element there will be in that compound. That's why carbon dioxide is called carbon dioxide, because there's 1 carbon and there's 2 oxygens. So the prefixes, very briefly, so mono is for 1. Probably also heard of carbon monoxide, that's where that comes from. Di for 2, tri for 3, tetra, which is the same root word as Tetris. That's why those blocks, that's why it's called that, is because the blocks have 4 squares. So tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9. A few of these are a little bit uncommon. 10, so like a decade is 10 years. Deca is going to be our prefix for 10. 1 plus 10 will be our prefix for 11, so it's called undeca. And then dodeca, like a dodecahedron that has 12 sides, would be our prefix for 12. We usually won't use those in here, but just in case you need them, there they are. The rules for naming these are a little bit different. So the first element, if there's only 1, then you just write the name. If there's more than 1, you must use the prefix. And the second element, you always use the prefix. And then the second element, whichever one it is, you add "ide" to the end, just like we did with the ionic compound. So for example, methane could be called carbon. So no mono because it's the first one. Carbon tetrahydride because there are 4 hydrogens. So CO, for example, would be carbon monoxide. Again, we don't put the mono on the first one if there's only 1, but carbon monoxide for 1 carbon, 1 oxygen. CO2 would be carbon dioxide, another you've probably heard of. And if you want to pause the video and try this one on your own, that would be great. I'll give you a second to do that if you would like. Okay, hopefully you pause it, and now we can try this. So this time there's 2. So I do have to use the prefix even though it's the first one. So diphosphorus for the first part. And then the second part, there are 6 fluorines. Since there's 6 fluorines, I need to use hexa as my prefix. I need to say fluoro, for the fluor, for fluorine, but I need to add the ides to the end because it's the second element. So diphosphorus hexafluoride. Okay, hopefully this is enough to help you understand both how do we make the structure of a covalent molecule, and then how do we actually name them once we have that formula. So CH4 could be called carbon tetrahydride if we didn't know that it was also called methane. All right, thank you all for watching. Hopefully this is a helpful video to get you through slide 14 in Digital Notebook number 14.